This is a review tutorial of independent samples t-tests. I highly recommend that before watching this tutorial, you watch the one that introduces independent samples t-tests and that follows along more closely in the student study guide with IBM SPSS Workbook. For this example, we'll use a data set not shown in the workbook. We have a data set here of baseball players, and we've collected information about the player's birth order, coded as firstborns equal 1 and laterborns equals 2. And then we have their batting average, which is the ratio of how many hits they made per times at bat. And we also have information about their grade point average, or GPA. Now let me sneak in a couple review questions. First, a question about research design. Is this study an experiment? If you said, no freaking way, you are correct. There is no way, it is impossible for us to randomly assign or manipulate an individual's birth order. Therefore, this is a non-experimental study, a correlational study, because we're looking at the relationship between birth order and batting average and GPA. Another review question. Birth order is what type of variable? Nominal, ordinal, interval, or ratio? And what is batting average and what is GPA? If you said birth order is nominal, you're correct. We have a grouping variable categorized as firstborns and laterborns for birth order. And if you said the batting average and GPA were both ratio variables, you're correct, because you can have 0 for both of these numbers. Now, when running analyses in SPSS, SPSS really looks at interval and ratio data the same way. So we could have interval data here and still run our independent samples t-tests. Let's go ahead and run our independent samples t-tests. And I'm going to run all of these at the same time. Go to Analyze, Compare Mean, Independent Samples t-tests. I'm going to put my birth order as my grouping variable. Define my groups. I've coded them here as 1 and 2. These values need to match what's in your data set. And then my outcome variables are both batting average and GPA. And if I had some other interval data, I could also put them as my outcomes here. And then I click OK. Now, here we have the output, and we see that our outcome variables are basically stacked on top of each other. So we have 2 separate analyses, but they're stacked here. We've got our descriptive statistics first for batting average and then GPA. And then we've got our independent samples t-test results first for batting and then for GPA. Now, this is a great way to do things to save time when you're a little bit more comfortable with SPSS and interpreting independent samples t-tests. And so if you're feeling pretty confident, go ahead and run analyses like this. However, if you're just starting off learning about independent samples t-tests and you realize that especially interpreting the output is challenging, then what I would do is just run them as separate analyses until you gain a little bit more comfort and confidence. And I'm going to go ahead and do that here just so that we can look at the output separately. The first step is to look at Levene's test to determine which line we look at. Can we look at the equal variances assumed line, or do we need to look at the equal variances not assumed line? Look at Levene's test and see if you can figure out whether or not we've met or violated our assumption of equal variances. The answer is that we've violated our assumption. We cannot assume equal variances because our Levene's p-value is under 0.05. It's 0.037. Therefore, when interpreting our t-test results, we would look at the information on the second line here. Look at the t-test results. Are they statistically significant or not? The answer is the results are statistically significant. Our p-value equals 0.01, and that's under 0.05, and we would have a statistically significant difference between firstborns and laterborns in their batting average. Look at the descriptive statistics shown in the first table to determine the direction of this difference. Here we see that laterborns have a batting average of 0.330, which is higher than firstborns, who have a batting average of .308. When we write up these results, we would include the mean and standard deviation for each of our groups. We would indicate that we violated our assumption of equal variances. We only do that when Levine's is statistically significant, otherwise we don't mention it at all. But here we'd want to note that we violated our assumption of equal variances, and we can see that there's more variation in the laterborns than in the firstborns. And then we would report our t-test results as shown here. Hit pause if you need a little bit more time to see where these numbers came from. We would also calculate and report a measure of effect, such as a point by serial correlation squared or Cohen's d. This is our output for GPA. Which line should we look at? Equal variances assumed or equal variances not assumed? We should look at the equal variances assumed line because our Levine's test was not statistically significant. The p-value is 0.39, which is over 0.05. After you make that determination, you do not need to look at Levine's anymore. You would also not include any mention of Levine's test in your results when you have a non-significant Levine's. Now look at the t-test results. Do we have a statistically significant difference between firstborns and laterborns GPA? The answer is no. These results are not statistically significant. When we write up our results, we would include the mean and standard deviation for each group, and we would report our t-test results as shown, noting that the results are not statistically significant. Hit pause if you need a little bit more time to see where these numbers came from. We would also calculate and report a measure of effect, such as a point by serial correlation squared or Cohen's d.